Hi, now we are going to discuss the solution of trigonometric equations of some specific values. Where means what I wanted to mean is that trigonometric equation where there is an unknown variable but the equation contains a specific values like 0, 1, minus 1 like that. So here it is, if sin theta is equal to 0, that implies theta equal to n pi, where n belongs to z, the set of integers. Okay. The next one is cos theta is equal to 0, that implies theta equal to 2n plus 1 into pi by 2, where n belongs to z, the set of integers. Next equation is tan theta equal to 0. This implies theta equal to n pi, where n belongs to capital N, the set of natural numbers. Please make a note of this n. It doesn't belong to the set of integers, rather it belongs to the set of natural numbers, and set of natural numbers is a subset of set of integers. Now cot theta equal to 0 implies theta equal to 2n plus 1 into pi by 2, where n belongs to z, the set of integers. You may think that why I have not discussed about the solution for cosec theta equal to 0 and sec theta equal to 0. Cosec theta equal to 0 is not a valid statement, or other way you can say, if we say cosec theta equal to 0, it is not possible to find any value of theta. Why? Remember my earlier class where we discussed about the graphical representation of sin theta, cos theta. We have seen the value of sin theta and cos theta is always between minus 1 and plus 1, including minus 1 and plus 1. Okay. Now the value of cosec theta, which is the reciprocal of sin theta, will be what? 1 by sin theta. Now as the value of sin theta between minus 1 and plus 1, the value of cosec theta should be either greater than 1 or less than minus 1. Let's see by means of mathematical calculations how we are going to get it. So here we see that minus 1 is less than equal to sin theta is less than equal to 1. This implies sin theta is greater than equal to minus 1. So from the principles of inequality, we can say that 1 by sin theta is less than equal to minus 1, right? The moment we make a reciprocal of both the sides of the inequality, the sign of the inequality gets changed. Those who have not covered my classes on inequality, please have a look into the video of that class. So this implies what? This implies cosec theta is less than equal to minus 1. And in the similar manner, we can say that sin theta is less than equal to 1. That implies 1 by sin theta is greater than equal to 1. That implies cosec theta is greater than equal to 1. So what we see? We see that cosec theta is either less than equal to minus 1 or greater than equal to 1. That means that cosec theta cannot attain a value 0. The similar explanation is true for sec theta is equal to 0. Sec theta equal to 0 is doesn't have any solution, okay, because it goes with the same logic. So that's why I have not discussed about that cosec theta equal to 0 and sec theta equal to 0 in this one. Our next one is actually sin theta equal to 1. Sin theta equal to 1, what it implies? It implies that theta equal to 4n plus 1 into pi by 2, where n belongs to z, the set of integers. And cos theta equal to 1, cos theta equal to 1 implies theta equal to 2n pi, where n belongs to z. Correct? Next one is coming sin theta equal to minus 1. This implies theta equal to 4n minus 1 into pi by 2, where n belongs to z, the set of integers, and cos theta equal to minus 1 implies theta equal to 2n plus 1 into pi by 2, where n belongs to z, the set of integers. Here I would like to say you one point. In my earlier class, we have discussed about the general solution of trigonometric equations by means of sin theta equal to sin alpha, cos theta equal to cos alpha, tan theta equal to tan alpha. Now, why we are discussing again with this one? Because we can really equate to this value. Sin theta equal to 0 means what? Sin 0, which is belongs to minus pi by 2, which is the requirement for sin theta equal to sin alpha, where alpha should be belongs to minus pi by 2 to pi by 2. Right? So we can write sin theta equal to 0 equal to sin 0. Then we can apply that general solution and we will get this kind of solutions only. So why I say again specifically for these values, it will, if you remember these solutions, it will help you to make a solution to a trigonometric equation questions very quickly. You can always apply the trigonometric solution, general solutions, what is that discussed in the earlier class, that is fine. But if you get these specific values, sin theta equal to 0, cos theta equal to 0, tan theta equal to 0, cot theta equal to 0, sin theta equal to 1, cos theta equal to 1, sin theta equal to minus 1, cos theta equal to minus 1, you can apply these solutions directly without computing the what will be the value of cos theta equal to minus 1 and how what cos will be of cos theta, what is the value of cos angle which will be minus 1, in this case it is pi, cos pi. In that way you no need to compute. If you compute in this way you will reach to this solution, but it will take some time. But what is the purpose? Purpose is that find a solution to a trigonometric equations question very quickly as possible. So if this is the purpose, then remembering these formulas are equally important. Correct. Now we are going to discuss about the trigonometric solution of a equation like a cos theta plus b sin theta equal to c. Okay. So what is the equation? Equation is that a cos theta plus b sin theta is equal to c, where theta is the unknown variable whose value we are going to compute, and ABC are real numbers. But these real numbers ABC is tied up with a relation What is the relation? Where mod of c is less than under root of a square plus b square, or I can say less than equal to. Why this relation is important, we will discuss while finding the solution. If we see, if mod of c is greater than square root of a square plus b square, it is not possible to find a solution to this equation. We will see why it is so. Let's first find a solution to this equation. Now, to find the solution to this equation, we need to take help of a translation, and that translation is generally known as the translation from polar coordinates to Cartesian coordinate. So we know that if xy is a Cartesian representation of a point and corresponding polar representation is r theta, what is the relationship between them? X equal to r cos theta, y equal to r sin theta, and r is under root of x square, square root of x square plus y square, which is a positive square root, right? Now, the thing is that we can approach the similar kind of translation here to find a solution. Let's see. What is that? We will assume that a equal to r cos alpha and b equal to r sin alpha. Then by means of these two translation, what we get? We get r equal to square root of a square plus b square. Right? How? Okay, let's have a quick evaluation. Let's square both the sides and add. Then what will get? A square plus b square is equal to r square into cos square alpha plus sin square alpha. That implies what? That implies r square is equal to a square plus b square. That implies r equal to plus minus square root of a square plus b square. Now, we should not consider the minus of square root of a square plus b square. Why? Because in that representation, in the polar representation, r is the length. Okay, and as it is a length, it cannot be negative. Okay, so r is known as the length of the radius vector. So we cannot consider the minus value. So here we will consider the plus value, r equal to square root of a square plus b square. See, it is very important to explain each and every logic with a proper justification to make a statement in mathematics. So this is a very generic kind of statement to you. So here r equal to plus minus root over of a square plus b square. So here you need to explain why minus is not a acceptable value. Why not? Why only we should consider the positive square root. Okay. Fine. Now another thing we can say, if we divide, what we get? That sin alpha by cos alpha equal to b by a. So that means tan alpha is equal to b by a. That implies alpha equal to tan inverse b by a. So let's give this equation as 2, equation number 2. So if tan alpha equal to b by a, alpha equal to tan inverse b by a, those who have not actually looked into my video lecture on inverse circular function or inverse trigonometric functions, please have a look into that video and you will have a very clear understanding about inverse trigonometric functions. Alright, so these are the two values we are getting here, r and alpha. Now, as we have considered these two translations, and if we apply here, what we will get? We will get a is r cos alpha, so r cos alpha into cos theta plus b, here it will be r sin alpha into sin theta is equal to C. So this implies what? This implies if we take R common, then we are getting cos alpha cos theta plus sin alpha sin theta. So what is that? If we take R common, we are getting cos theta into cos alpha plus sin theta into sin alpha is equal to C. This implies cos theta cos alpha plus sin theta sin alpha, it is cos theta minus alpha. So this implies cos theta minus alpha is equal to C by R. Alright. So that implies cos of theta minus alpha is equal to, let's take it as a cos beta. We are assuming where cos beta is equal to C by R. Let's assume we will replace the value later. Now here is the case that cos beta equal to C by R. What does it mean? What is R? That is equal to C by square root of A square plus B square. Now we know the value of cos beta is always less than equal to 1. Right? So we know that value of cos beta is always less than equal to 1. Value of any cos means cos theta is less than equal to 1 for any value of theta. Now that means C by root over of A square plus B square is less than equal to 1. That implies C is less than equal to root over of A square plus B square. So that is the condition. And why it is mod C? Because this value is positive. Okay, so whether it is minus or plus, that should be always less than equal to square root of A square plus B square. So if we see that C is greater than square root of A square plus B square, then it is not possible to find a solution to this equation A cos theta plus B sin theta equal to C. Now you understood? Good. So anyway, let's come back to our solution. So cos theta minus alpha equal to cos beta. So what is the solution? We know the solution to this equation is equal to theta minus alpha equal to 2n pi plus minus beta, right? Cos theta equal to cos alpha is theta equal to 2n pi plus minus alpha, where alpha belongs to the closed interval 0 to pi. Good. So that implies what we get, theta equal to 2n pi plus alpha plus minus beta. Now let us apply the value of alpha and beta whatever we have computed so far. So alpha is tan inverse b by a. So this implies theta equal to 2n pi plus tan inverse b by a, and plus minus what is beta? Cos beta equal to c by root over of a square plus b square. That means beta equal to cos inverse c by root over of a square plus b square. So it is cos inverse c by root over of a square plus b square. So this is the general solution to the equation. Where n belongs to z, the set of integers. Clear? We have reached the end of the discussion of trigonometric equations. The last topic is that if you see a value of a trigonometric function, okay, and trigonometric functions means suppose it is given cos theta equal to k. K is the value. Now for what all values of k you can find a solution to the equation cos theta equal to k, we are going to see, like cos theta for the other 5 trigonometric functions as well. Okay, so that we are going to discuss here. So think I can rub this portion. Okay. So if I have this thing sin theta equal to k, this equation where k is a known value and theta is an unknown value, whose value we are going to compute by means of a trigonometric equation sin theta equal to k. But when that solution is possible to have, when we can have the value of theta so that sin theta equal to k, the condition is that k should be in between -1 and +1. So this is only possible is when -1 is less than equal to k, less than equal to +1. That is only possible. Then only we can find the value of a solution sin theta equal to k. The similar thing is applied for cos theta equal to k. That means -1 less than equal to k, less than equal to +1. Tan theta equal to k doesn't have any such restriction on k. K could be any real number. If you remember the graphical representation of tan theta, if you just memorize this thing right now, you will see that tan theta can be of any value, right? That is real number. So here the only constant is that k should be belongs to the set of real numbers. The same thing is applicable to cos theta equal to k, where k should be belongs to the set of real number. Now cosec theta equal to k, if we say what will be the acceptable value of k so that we can find the solution to the equation cosec theta equal to k. Here k should be either less than equal to -1 or greater than equal to +1. So the condition is that either k is less than equal to -1 or k is greater than equal to 1. The similar condition is applicable for sec theta as well. Sec theta equal to k, that is means either k is less than equal to -1 or k is greater than equal to 1. Under these conditions on k, we can find a solution to these trigonometric equations. So we have reached the end of the discussion of trigonometric equations. Solve as much as problems you can do. Okay. Any questions, any issues, please do contact me over email. The point is, those who are having my study material and unit test question paper, please proceed with that. Those who are not having this thing, please do contact me over email and I will send you the same. And here is my email address. My email address is konar, KONAR .classes CLASSES @gmail.com. This is my email address. Please do contact me for any kind of clarification. I will be happy to assist you. Okay. Till that time, please solve as much as problems from trigonometric equation as possible, and you can take assistance of NCERT books or the previous year question papers of IIT joint entrance and the unit test question paper what I deliver. Okay, thank you.